So, hi, today I'm going to discuss what's the difference between a process and a thread. So, what is a process? So, for example, you started Google Chrome, that could be called a process, and you started a Zoom call. That's a separate process. Because both of these are two separate uh, applications. We are calling these two different processes. So a process has its own memory space in the disk, the RAM to run. It it has its own resources like descriptors and sockets, and processor are basically isolated from each other. That is a uh, Google Chrome is running on a specific part of memory which cannot be accessed by the uh, Zoom, which is running on another part of the memory. So yeah, and when we'd want to switch from one process to another in like for example, only a limited number of processes could run on a core on limited code. So when we need to run other process, we need to do context switches, context switching. That is switching from the switching the current memory and allocating it and making it available for the current process. For example, we are currently using Chrome and we have only a single processor, single core in our computer. So the com- wo- the OS, what it does, it switches the context by saving the current state, the current memory, the current uh, like other thing of the Chrome, and then it starts running Zoom. Then when we need to return to Chrome, but we need the it should return from the exact state we had left it. We need to do context switching. So it is generally expensive in the case of a process. But in the case of a thread, so in the case of thread, we are fully trying to utilize all the cores of a computer. So basically, a thread is a smallest unit of execution inside a process. So what it helps basically is it helps fasten the process. For example, there are multiple tabs open in your Google Chrome. So each tab is handled by a separate thread, and thread uses shared memory. That is, it don't uses different memory because it is still inside the same process. Each stack is each thread has its own stack and registers, and context switch is generally cheaper because they are using actually the same memory. So the high level difference between the two is the creation cost in the process is high, the thread is low. Context switching is expensive in process, but is cheaper in the case of a thread. Isolation is very strong in case of a process. That is one part of a uh, one process cannot access memory of another process, but one thread can access the memory of another thread in the same process. So the crash impact is basically if one process crashes, the other process, like if Zoom crashes, my Chrome process is unaffected from it. But in the case of a thread running in the same process, if one thread crashes, the whole process may crash. So why are threads? So threads are usually faster, as I discussed. Ki there is no need of context switching. Shared memory is used, and that avoids copying of data and context switching. So why don't we actually always use thread? So thread also has some drawbacks. For example, uh, let me say you have four cores in your computer, but you accidentally define 100 threads. So it may lead to oversubscription problem. So there's more threads in the CPU code, then the context switching might not work, and the CPU spends more time switching the context between the threads. So it may actually be slower than the creation of a process. Another thing is, for example, you are using logs, and all the threads or some of the thread, like for example 10 threads are trying to access the same resource, but like it has a lock on it, so no matter what, it still leads to the same time, because only one thread at a time could access the resource. It could also lead to the problems like deadlock, etc. Ki one two threads are trying to access the same resource. No, sorry, deadlock is not that. One thread has one resource, second has another. There is mutual exclusion present. Preempting is present. That is a no. None of them will release the lock until it gets the resource. So it could also lead to that problem, and there could be also a problem of cache. Problem that is this threads usually use the cache inside. Uh, Stores in the memory, that is the cache. So due to frequent updating or creating of too many threads, it might be the case ki you may face a high amount of cache misses, where which is not generally prevalent in the case of single in prevalent in the case of process multiple process, but it is present in multiple threads case. Yeah, so that's all for this video. Thank you.